So your question is why we are taking the infinite resistance across current source. Okay.
Yes.
So like for example, I'm taking a case where this is my current source. Okay. In the current source, the internal resistance are connected in parallel. So this is I say the resistance of the supply signal. Okay. Now this is a one resistance R. Okay. Now if I current will be flowing from this one, so it will be go one is this way and one is this way. I1 and I2. What is the value of I1? I apply the KCL current divider biasing rule. So
I
value of
minus V.
I1 I minus I2, or if I calculate in terms of resistance, so I1 is
R by
I
RS plus R.
upon R plus RS.
Yes.
Okay. And what is the value of I2? I into RS upon R plus RS. Okay. Now if R I am taking infinite, RS I am taking infinite. So what will be happen? I into R upon R plus infinity. So denominator term will be infinity. That means current I1 is 0. Okay. And second case, I multiply, I am taking RS common from the denominator side and cancel out. So 1 upon 1 plus R upon RS. Okay. And if RS is infinity, this term becomes 0. So that is I multiply by 1 upon 1 plus 0 becomes I. Okay. So the to deliver maximum current in the load resistance or some other resistance in the circuit, we particularly required that my source resistance should be infinite. Okay.
Uh, yes, sir. So why this resistance is always connected as a parallel thing?
Basically, when we are going, when particularly we are talking about the current source. So in the case of current source, this is the condition that my current is divided in parallel. Okay. Whereas current is constant in series. Okay. Now if I am taking, I just take one example that you are using all are using the mobile phones, and my mobile phone battery is like for example 5000 mAh. Okay. But what is the meaning of this one? That means it's provide 5000 milliampere current for 1 hour.
1 hour.
Okay. But exactly it is not 5000. It is 4850 milliamp or 4850 or 4900. That's as per the particularly which type of mobile phone you are using. Okay, so this is this much. Now if suppose for example my resistance are connected in series. This is the current source. This one. Now due to this resistance RS, if I'm connecting RS resistance in a series, so is this resistance create any effect in the current value?
No, sir.
No. So that means it is doesn't mean that which type of battery I am using. Like I am using a basically if we say that the highly ideal battery, okay, or if I am using a poor battery. So in every scenario, my resistance, my particularly current should be constant. Okay, if this will be happen, so what is the reason that after several times, after several cycles, my battery will be damaged? If you are saying, like, if I'm using a battery for in my bicycle, or basically my motorbike, so you see that after 3 years the battery will be completely discharged. Okay, so what is the meaning of this one? The meaning of this one is the resistance increases because there are some chemical processes done, and due to this chemical process, my resistance are increases, and it is increased in a way. Okay, so basically it affects on what particularly current I just provide. Okay, but if my resistance are in series, so there is no issue with the battery cycle, with the battery duration, with the anything of the battery life cycle. Every time it provide the maximum current to me. So that's why for the current source, we are assuming my battery resistance are connected in a series parallel, not in series. Because if I connected in the series, there is no effect of that resistance. There is no effect of the battery quality.
Yeah, yes, sir. Uh,
Okay.
yeah. So
Similarly, if I
likewise
am
in
yeah,
yes, sir. Yeah. Yes, sir. Go on.
in case of voltage source, it is
Yes.
in series. Why?
Yes, sir.
Because voltage will be changes in series when resistance will be connected in series, not in parallel.
Yeah, correct.
Okay, so that's why we are assuming that for voltage source correct basically connected in parallel and sorry in series, and in the current source it is in parallel.
Yes, sir.
Any other doubts?
Sir, in practice assignment one,
Hmm. Yes,
um, I think in question,
there are some values are missing. Practice
yeah,
assignment.
yes, sir. V in should
V in
there be?
values are missing.
Yes.
Okay, so that is basically if you take the for the question second, it the value is around 10.
Okay, sir.
That is by mistake.
Yes, sir. So we need a V in, right? V in value
Yeah,
to find the answer. Okay.
yeah.
Yes.
V in value is required for calculating the V out. Okay.
Yes, sir. Okay.
Any other doubts?
Sir, I have one doubt in one of the lectures from week two.
Okay, no problem. Go ahead.
In lecture three.
Lecture 3. Can you tell me the topic basically? Let me
Yes, sir.
check.
A difference amplifier.
Differential amplifiers.
Yes, sir.
Okay. Yes, tell me your doubt.
Yes, sir. So in the video, around the timing 10 minutes.
Differential amplifier. Eh, Let me check. Lecture third. 10 minutes.
Yes, sir.
Mm, mm. Yes, tell me.
Yes, sir. So here,
Mm,
the professor is finding whether the what sign should be on A1, the amplifier one,
uh,
whether minus should be on top or plus should be on top.
for the
By
second one. For the second one.
no, sir, for the yeah, the second diagram, first
Yes.
amplifier.
Yeah, first amplifier.
Yes, sir.
Basically, the thing is that if we are using, like, for example, I just take this one. Mhm, mhm. This is the circuit. Okay. So
Yes.
for basically find out that what is the particularly value in this scenario. So what we do, we just break a loop. Okay. So our
Yes, sir.
loop is this one. If I put it marked, my loop is this one. Okay. So this is my loop. Now I just delete. I just break the loop. Okay. So from here I just break the loop, and what I do, I just slightly change the voltage. Okay. So if it will be changes, so here we are getting the change voltage in a positive direction. Now if I am taking that this is a plus signal, so if it is increases, so it will be here increases. Okay. Again, if we go in the this direction, it will be increases, and with the minus sign, it will be decreases.
Yeah, yes, sir. So here, um, there is a two-way to V out, right, sir? One is through the resistor, and the other is through the amplifier, the negative
Uh,
terminal.
for the second one, register or second amplifier,
Yes, sir. The in the second
for
amplifier.
R2, R3, and R1.
Yes, sir. So from
Okay.
R3 to V out,
R3 to V out. Okay.
we have two ways to reaching for reaching V out, right? Through R2 or through the amplifier.
Through the R2 through and through the amplifier. Okay. Now the
Yes.
thing is that
Uh,
now thing is that when we are going to the operation amplifier, okay,
yes.
and my loop is the negative feedback. Okay. To solve this type of feedback, what is our consideration is that my operation amplifier will be work as a virtual ground concept.
Yeah, yes.
And what is the virtual ground?
Here the meeting point of R3 and R2.
The basically the voltage V minus is equal to V plus.
Hmm.
That means the voltage at this point and the voltage at this point is same.
Virtual short, right, sir?
Yeah?
Virtual short.
Yeah, virtual short or virtual ground condition, we say that.
Yes.
Virtual short or virtual ground condition. Okay.
Yes.
Now, what is the basically consideration of this one is that, like if I am talking about the operation amplifier, so my operation amplifier will be like that. This is the V1 voltage, this is the V2 voltage. Now the drop across this one is V1 minus V2. Okay. Now the drop across this resistor will be produced as a current in the operation amplifier, and the current value is A times V1 minus V2. Okay.
Yes, sir.
Now if I assume that V minus is equal to V plus, that means V1 equal to V2, or V1 minus V2 is equal to 0. If V1 minus V2 is 0, that means the value of this source, either it is a voltage or it is a current source, the value of this source is A time V1 minus V2 becomes 0. Okay. And what we are getting here? We are getting here 0. So that means if my operation amplifier work in virtual ground concept, no current flow from op amp. And from where the current will be going? Current will be going in this direction.
Yes.
Okay. But
Yeah.
for the checking of the positive and negative feedback, what we are consider, if I apply the voltage at a negative terminal, or either it will be going to this side, so the voltage because of negative terminal will be negative at output side. Like if I provide the V in voltage at a negative terminal or inverting terminal, what we are getting out? V out is equal to minus V1 times Rf upon R1. That means it is a negative inside. Okay. So if voltage are increasing at this point, so that means what is the voltage at output side? It will be decreasing.
Mm.
And what is the meaning of decreasing? The meaning of decreasing is that, like, if I am say my 2 is less than 3, okay, and I multiply both value with the minus 1, so minus 2 will be greater than minus 3. So that means if this value is increases and I multiply this with the minus sign, so it will become decreasing value. Okay. Now I apply the signal, small signal changes in a positive direction, and I am getting revert back in a loop that is in negative in direction. So I can say this is the 180-degree phase shift, and if 180-degree phase shift, that means negative feedback.
Yeah, yes, sir.
Okay. So professor is saying, say first of all, professor is asking that what is the particularly terminal of the operation amplifier. So terminal of operation amplifier is basically we have to decide according to, in a way that we are getting a negative feedback, because till week 2 or week 3 professor is not discussing any about positive feedback. They are always only discuss about the negative feedback.
Yes, sir.
Okay.
So for this, we should not follow the R2, but the amplifier A2, right,
Yeah.
sir?
If you feel like professor break from this point.
Yes, sir. Correct.
Okay. And they are saying that if we are positive and negative, we are getting the reverse voltage. Like, yeah, this one. Okay. So this thing.
Yes.
Now,
Okay.
the if you are basically calculating the output voltage. So what is the output voltage? If we have two circuits, R1, Vi, this become grounded, minus sign. This is the R4, R3. This become negative. This become positive, grounded. This becomes R2 and V out. Now, what is the output voltage?
Yeah. Minus Vi by R1 into R4.
Minus
Yeah.
Vi
Vi
into
by R4
R4
by
by R1.
R1.
Okay. So if you see that there is no effect of R2 and R3
Yes, sir.
for actually the V out. Why? Because this is the virtual ground. These 2 points are virtual ground, so current will be going from outer side. So this is the direction of current, and we are getting the output here because of this. And the value is minus Vi R4 upon R. Okay.
Yes, sir. Um, and sir,
Now, if yeah,
yes, sir. Yeah.
if we are taking the voltage at this point, so this is the difference. Okay, so I think professor already discussed that this what is the voltage is this point. This is the R3. Okay. So we are getting output that is the minus Vi RF R4 upon R1. Now if I say that what is the voltage at this one, I put it V out 1. So V out 1 we are taking because of this one, because we know the V out. With the help of V out, I calculate the V out. Okay. Can I explain it?
Yes.
So like I am taking the Vx. V out 1 is the Vx. So what is the relation between Vx and V out? So V out is Vx. It is again a negative feedback. Sorry, because of this one is the minus Vi1 plus R4 upon R1.
Yeah. Yes.
Okay. And what is the relation between the Vx and V out? If I am taking Vx or V out one is same. So the relation between Vx V out is V out is equal to minus Vx into R2 by R3. Okay. So the value of Vx is minus V out into R3 upon R2. And V out values we have already calculated. So that is equal to minus Vi 1 plus R4 upon R1 into R3 upon R2. That is the value of Vx. And it is V out.
Sir,
Yeah.
uh, in V out, why we are including the 1 plus?
Basically, the V out, if we are talking about the V out, is only because of Vi. Okay. And Vi is connected on a positive terminal.
Yeah.
Feedback is negative but positive terminal. That means it is behave as a non-inverting amplifier. And what is the gain of non-inverting amplifier? Vi into 1 plus Rf upon R1. So Vi into 1 plus R4 upon R1, that is the V out.
Um, but it will give the Vx, right, sir? Okay. But here, since it's a virtual ground,
Yeah,
uh,
virtual ground for all. Virtual ground for both. What
okay.
what we do first step is that we are calculating the V out. Okay, and V out is mainly because of this one. If I calculate the V out upon with respect to the input voltage Vi, so my Vi is this one. My V out is nothing but Vi into 1 plus feedback resistance upon input resistance. So 1 plus R4 upon R1. Okay, so we are getting the V out. Now, after getting the V out, if I calculate the V out at this point, operation amplifier of first, so what I do, I know if I know this particularly value, if I know this voltage, I can calculate the V out in a way of inverting amplifier. So, with respect to this V out one, my V out value, I want to calculate the formula is V out is nothing but equal to minus, why minus? Because it is connecting in a inverting amplifier. So minus Vx or V out 1 into R2 upon R3. Feedback upon input. Okay. But we have to calculate the Vx value. So the Vx value is nothing but minus V out into R3 upon R2. Now V out we have already calculated in terms of Vi. In terms of Vi. So V out is sorry Vx is equal to minus Vi 1 plus R4 upon R1 into R3 upon R2. Okay. Yes, any doubt? Yes, any doubt?
Sir,
Yeah.
in the lecture, I think the professor derived it in a different form. I mean,
Mm,
it didn't include the one plus factor.
just a minute. Oh, yes, professor is taking minus R3, R4 by R3. Yes, yes, yes. But it's 1 plus R4 by R3.
Yes. Or will it come only when the amplifier is in single thing and not as a combined form?
No, 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 no. There is no effect of this. You have to check it is a working as a inverting or non-inverting amp.
Yes.
Okay, and that will be decided that the input voltage Vi is connected on a negative terminal or positive.
Yes.
Okay.
Um, so here, sir, is the collective, I mean, collective combination of these two amplifiers, does it work
Yeah.
as inverting or a non-inverting amplifier combination?
Basically, the first amplifier will be working as a. If you are talking about the, it is working as a non-inverting, and
Non-inverting.
second will be the working as a inverting.
Yes.
Okay. If you
Yeah.
are connected 5 or 6 amplifier again in a cascade form, so it is all dependent on which type of connection configuration you have used. Okay, maybe possible that every operation amplifier will be work in a form of inverting, non-inverting, inverting, non-inverting in a way.
Yes.
Okay,
Okay.
so there is no particularly effect of this one. Mhm. Yeah. Any other doubts?
Sir, likewise in lecture 4,
Mhm.
uh, there is some new concept of negative impedance.
Lecture 4.
Yes, sir.
Okay, a minute.
Uh, Howland.
Okay, Holland pump.
Yes.
Yeah, yeah. Basically, the concept of the Holland pump is that uh, basically it is a Holland current pump, not Holland pump. It is a
Yes.
Holland current pump. So basically, the concept of the Holland current pump is that if you are using any voltage source, okay, and you convert this voltage source in a current source in a way that the current value is independent on load impedance. Okay, so it is basically the concept of Holland current source. Now, the thing is that mm, if we have a voltage source, V test R mm, ZL, yeah, this is your circuit. Okay, this is your circuit. Mm, RF. Yeah. Now the concept is that if I use this circuit in some other configuration, okay, and what is the some other configuration is that if this voltage is Vx and this voltage is y Vx, okay, because virtual ground concept, okay, if it is a V in, so the some voltage will be drop across the resistor, so this voltage Vx, the value of the voltage Vx is V in minus I time R. Okay, now if this is the voltage, so I am taking this, the voltage is same. Okay, because it is a virtual ground concept. Okay, now if I calculate the current here, so what is the value of current?
V in minus Vx by R.
V out minus Vx by R.
Oh,
Okay, because current is going from this way, so this, if
yes.
this is the voltage V out, so this is the V out
Ah,
minus Vx by R. So current I is nothing but V out minus Vx upon R. Now this current is not dependent on ZL. What is the value of ZL? Okay, it is only dependent on V out minus Vx upon R. It is not dependent on ZL. Now V out is dependent on what? V in, this resistance is this RF. Okay, so V out is dependent on V in, R and RF, and Vx is dependent on what? V test R or V in R. Clear? Because this voltage and this voltage both are same, so either it is dependent on V in I and R, or I can say the V test R or I test. And what is the I test? I test is the current flowing in this direction. Okay, any doubt?
Yes, sir.
So the current that is coming in this direction, it is dependent on these two factors, and these two factors is dependent on V in R, RF, or V test, R, I test. It is not dependent on any of the value of ZL. Okay, and so if current is sorry not dependent, current is not dependent on ZL value. So if we are using ZL value low or high, current is constant for both cases. Okay, and if current is constant, so can I use this current as a source? So it become behave as a current source.
So this acts as an ideal source, right, sir?
Which one? We said
This current source.
this current source is not a ideal. It is dependent on some parameter, but it is not dependent on the load resistance.
Okay.
Okay,
Um,
like for example, I have a multiple mobile phones. Okay,
yes.
every
Yes.
mobile phone has a different battery. Okay, and maybe possible the resistance value of every mobile phone battery is different. Like if you test that when you are using original charging cable, so your mobile phone will be getting charged a quick faster, whereas when you are using the local, so your mobile phone will be charging a slower. Okay, why? The resistance values change. Okay, so in this way, if I change the load value, my load is maybe mobile phone, my load will be maybe the power bank, my load will be anything. Okay, that will be operated on a 5 volt, and the plug yeah, basically the plug socket will be similar size. Okay, so if I use any of the particular device, the load is different, but current is constant for them. Okay, so it's behave as a current source. So if I am using a voltage source and convert this particular voltage source in a current source using the operation amplifier, so it is called the hollow out current form.
And sir, so this V test with the series resistance R.
V test with the series resistance R because it is the internal resistance of V test.
Yes.
Okay,
So will it be changed into a current source with a parallel resistance R?
yeah, you can do it change.
Okay. Yes. Source transformation.
Okay, V
Hmm.
test with the series resistance R provide the current source I test. Okay,
Yes.
now in place of V test and R, I can use the I test or R in a parallel.
Yes.
Just any other doubts?
Um, yes, sir. So in this video, here professor mentioned that it has a negative impedance. He used this term also.
Negative impedance is why? Because the concept is that they are using the resistance value. Okay, R is the
Uh,
resistance value. Okay, and with the R, you can see that this particularly operation amplifier is connected in a parallel concept.
yeah, correct.
Okay, now if I am using that, if this particularly operation amplifier will be behave as a virtual ground concept, that means no current will be flow inside.
Yes.
Now if I say that, and this is my operation amplifier, where both terminals having the voltage as a Vx and Vx. Okay, if both voltage are same due to the virtual ground effect, okay, so no current will be flow. Okay, and if No current is flow. That means the particularly resistance is infinite. So resistance is infinite. Okay. Now the overall resistance is infinite. The overall resistance is infinite. How this overall resistance should be infinite? I am having one resistance with the value of R. If I add or subtract one more resistance with the R value, subtract one more resistance. So in this case, 1 over R total overall impedance, overall resistance value should be equal to R test. So 1 upon R total is 0. Okay. And that means R total is infinite. So how we achieve this R total infinite? If I connect one resistance minus R in the parallel of
Or
this R.
yeah, yes, sir.
Okay. So this is
Yes.
the basically condition that we provide the some particular resistance that is having higher value.
So, sir, how can we have a negative resistance?
So if suppose for example if I am taking that mm, negative resistance is practically not possible.
Yeah, yes, sir.
Okay.
Mathematically,
Uh,
we need negative resistance, but
yeah,
what we do
resistance
in real life?
in real life. Uh, the professor tells.
Yes, sir. Actually, professor didn't go in depth in
Yeah, professor
explaining what is
didn't go
negative
in the
resistance.
depth. Basically the concept of the negative resistance is that either if I provide the resistance that is equal to zero,
Okay. Yeah.
okay, not exactly the negative resistance. If I provide a short circuit
Correct. Okay.
resistance, so if the resistance value is zero, so 1 upon R plus 1 upon 0 infinite.
Or, sir, or otherwise,
No,
negative
no, 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 no.
resistance, does it mean we should pump current to the other side to balance it? Or
Yeah, basically the concept is that like if we are talking about the in some applications, so like for example I am taking one VI characteristics.
yes.
Okay, basically when I increase the voltage my current is increases.
Correct.
Okay, like if this is my the maximum limit where you are understanding the concept. And actually in scenario what is the particularly condition is that my current should be higher than the maximum current value. Okay, or maybe my voltage is higher than the maximum voltage. You see this type of graph in future subjects. Like if we are working on the graph, so maybe it will be increases and after that it will be start decreasing. This is my maximum limit V max, voltage V. This is the I. Okay, so if at a certain time my voltage will be higher than the maximum value voltage and after that it will be start reducing. Okay, so this type of phenomena will be shown by some devices, some electronic devices, like your transistor sometimes shows this particularly. At a certain limit my transistor will be working better. Okay, my transistor Vi characteristic is similar to the that we have seen in a theoretical concept, but after that, particularly beyond limit, your voltage sometimes increase, and after that it will start decreasing.
Yes, sir.
Okay, so basically if my voltage or basically a current will be increases with the higher value, with the maximum value. Okay, so we can say my resistance will be in this scenario will be negative. Like for example, I say that conductor. You know the conductor,
Yeah, yes, sir.
conducting material. Okay,
Yes.
so what is the effect of the temperature? If I
As the
increase the temperature, I can say the
conductivity decrease,
conductivity decreases.
yeah,
Okay,
resistance
but
increase.
resistance increases. But when I start increasing the temperature, okay, if I start the temperature increasing, so somehow initially it will be increases, and after that, if I increase the beyond this one, so my conductivity will be start decreasing.
Yeah, correct.
Okay,
Yeah, yes. It will vibrate
so
more electrons.
yeah, initially if I provide the little minor vibrations, okay,
Correct.
so it will be vibrating more, so my conductivity will be increasing. After
Mm,
that, if I increase, the range is very less, but if I put my conducting material at this range, my conductivity increases, and after that it will be decreasing. Okay, so basically concept is that it will be increases. Why? Because there are some vibration will be created, and that will be help to increase the conductivity.
yes.
Okay, so my if
Yes.
my temp with the respect of temperature, my conductivity is increases, so I can say my temperature or my resistivity effect will be resistance will be negative. That's why the conductivity increases with the maximum value.
Hmm. Okay. Yeah.
Okay,
Yes.
so that's particularly concept is called the negative resistance concept.
Hmm. Yeah. Yes. So the decrease in resistance is the negative
Yeah,
impedance.
yeah,
Ah.
decrease the
Yes.
resistance with the minimum limit, it is called the negative resistance.
Yeah. Yes.
Any other doubts?
Sir, are you in discourse forum?
Yeah,
Okay.
I
What,
just create a poll also, I just create a poll also for the
in
class
forum?
timing. Yeah.
Uh, in discourse forum or in G space, sir? I saw in G space and I voted it.
Yeah, in G space, G space.
Okay.
Discuss forum I have.
What's your
The name.
username ID?
Uh, that is, I think, Ankit S. Agrawal.
Okay.
Let me check. I will share with the particularly in a G space my
Yeah, sure.
ID.
Yes. Sir.
Any other doubts? Yes, any other doubts?
Sir,
Yeah.
I have a doubt in practice assignment 2.
Yeah, tell me.
In sir, question 2, I'm getting 5, but answer is -5. Could you explain?
Let me check. Wait a minute. Mm, Practice week 2.
Yes, sir.
Which question?
Question 2.
Mhm. Okay. The current I flow in the circuit for a given of V naught is 5 volt. Okay, so if V naught is 5 volt, anyone solve this question?
Uh,
Yes.
it's a, yeah, yes, sir. So it's going from 0 to 5.
Yeah, V naught.
So the answer should be in minus
Yeah, exactly. We are where we are connected the voltage current source
ground 0. I mean,
with
the
the
virtual.
negative terminal.
Yes.
Okay, so we are connecting our current source here. This becomes grounded.
Sir, I think your skin is not visible.
Yes, yes, share. I'm sharing. I'm sharing my screen. Yes. So this is the resistance 1 kilo. The question check. Please check the question. It is correct or not. Okay. So if I current will be flowing from this direction, it will be go in this direction. Why? Because again we are taking this is a virtual ground. That means the current going inside the operation amplifier is zero. Okay. If current in this operation amplifier will be zero, so that means current will be going in this direction. What is the value of current? Uh, Voltage drop across this one. I multiply by 1 kilo. And what is the direction of the voltage? This become positive. Why? Because current is entering this side and current is leaving this side. Okay. So I multiply by 1 kilo and this one will be equal to the minus V naught. Why minus V naught? Because the voltage drop across this one is appear here, where I negative terminal will be connected with the V0. So that's why the voltage at this terminal will be just negative of this voltage, negative of this voltage. So V naught is equal to I multiply by 1 kilo ohm. That means I is minus V naught upon 1 kilo ohm. Now what is the value of V naught? 5 volt. So if 5 volt multiplied by 1 kilo ohm, that is equal to minus 5 milliamp. Getting?
Yes, sir.
Any other doubts?
Sir, yes, sir. In question 4.
Question number 4. Yeah. The output voltage is of the pressure amplifier is when V1 is 1 volt and V2 is 400 millivolts. 5, 70, 25 and 50. Mm. 5 kilo ohm, 70 kilo ohm, 25 and 50K. Right, 25, 50. V1 is 1 volt and V2 is 0.4 volt. So it is a negative, positive, connected with grounded, 1 volt and 0.4 volt. Okay. So first of all, the current in this direction is in this branch is, if I am taking it is I1 current, and the current in this direction is I2. So value of I1 is equal to 1 divided by 25K. Okay, and current in I2 branch is I2 is 0.4 divided by 50K. Okay, now again the virtual ground concept. The voltage at this point and voltage at this point will be same. Okay,
Yes,
so
sir.
if I say that the voltage at this point, what is the voltage, or I just directly apply the this is the inverting amplifier, non-inverting amplifier. So what is the value of non-inverting amplifier? V out is equal to 1 plus Rf upon R1 into V in 1 plus 1 upon Rf upon R2 hmm,
Sir, is this fifth question?
this is the fourth question, no?
Sir,
No,
in
that is also how we use it.
Yeah, it is in fifth question.
okay, yes.
Okay, because you are shown this one is the two different questions.
Correct, yes.
It is the fifth question. Yeah, 1 plus, yeah. So now we are taking 1 plus Rf by R1 and calculating it. Can anyone calculate what is the voltage here we are getting? Yes, anyone? We are using, first of all, we calculate the gain. What is the value of AV? Voltage gain, that is equal to 1 upon Rf upon R1. That is equal to 1 upon 70K upon 5K. 15. This is the key. Any doubt in this?
No, sir.
Okay. Now, if no current will be flowing in this direction, this current will be going in this way. What about the current this way? That is coming from this point and this point. The current will be become zero. So addition of these two incoming current will be zero. Why? Because it is not going anywhere. It is just coming this side because no current will be going inside. Okay. So if I say for non-inverting terminal, total I is nothing but equal to I1 plus I2, and that becomes 0. Okay. Now put the value of I1 and I2. So 1 upon 25k plus 0.4 upon 50k. That is 1 upon 25 is 0.04 plus 4 upon 50, 0.008 milliampere. That is 0.048 milliampere. That is the value of current. Okay. Or now, if we say that what is the voltage at this point? I1. Okay. If I want to calculate what is the voltage at this point. So how should I calculate the voltage? I assume this is voltage is the Vx. Okay. So current is coming from this way to this way, and current is coming from this way to this way. So just I put the apply the KVL at this point and calculate that 1 minus Vx upon 25k plus 0.4 minus Vx upon 50k, that becomes 0. Okay. And from this way I can calculate the Vx value. So what is the Vx value?
800 millivolt.
1 upon 25 k minus Vx upon 25k plus 0.4 upon 50k minus Vx upon 50k. That becomes 0. So 3Vx upon 50 is equal to 0.048 into 10 to the power minus 3. So Vx is 0.048 into 50 divided by 3 millivolt. Okay. So now you get the value 16 multiplied by 50. That is 800 millivolts.
Yes, sir.
Now, if this Vx is 800 millivolt, that means the voltage at the negative terminal point is also same
800 millivolt. Yeah.
800 millivolts. Now, if the voltage at this point is 800 millivolts, so what is the output voltage?
800 plus um,
If this
800
voltage is
into
800, if this voltage is 800 and this voltage is also 800, okay, so the current will be flowing from this direction. So what is the voltage?
Mm, 800 into 1 plus 70 by 5.
Uh,
It will give us in millivolts.
if I put that 0, 0 is why? Because it is a grounded. 0 minus 800 millivolt upon 5 is equal to 800 millivolts minus V out upon 70. Now, no, actually, if it is a 800 millivolts, so I directly apply the formula. V out is equal to V in 1 plus Rf by R1. Okay, and 1 plus Rf by R1 is V in 800 millivolts, and 1 plus Rf by R1 15. Okay,
Yes, sir. Yeah.
so 800 multiplied by 15, that is 12 volts.
12.
What are the output? Yeah, 12 volts.
Yes, sir. Answer in question 3, part 2. How
Yeah,
the V output becomes 0 millivolt?
again you are taking this is the non-inverting summing amplifier, so the formula is what is the formula? V out is equal to minus Rf by R1 into V1 minus Rf by R2 into V2 minus Rf by R3 into V3. Okay, now put all these values. So what are the values? 10 minus 40 and 0.25. Okay, R1 is 20, 40, 50 and 200. So V1 RF is 200 by 10, V1 minus 200 by 20, V2 and 200 by 40, V3. Sorry, 20, 40 and 50. So I just take this 20, 40 and V out. So V out is equal to minus 10 V1 minus 5 V2 minus 4 V3. Now put the value of V1, V2, V3. What are the values?
Minus 10.
10 minus 40 and 0.25. So 10 minus 10 is okay, it is 25, not 0.25.
Yeah, yes, sir. I too had the same.
Yeah, it is a 25. So minus 100 plus 2 100 and minus it. If it is a 25, so it is again a minus 100. So it becomes 0 millivolt. Okay, and if I am taking the 0.25, so it is a 99. If V3 is
Yes, I'm
0.25,
getting 99.
so it is become 1, so we are taking the 99 millivolts. Okay, so if it is a point, if you are
Yes,
considering
sir.
with the 0.25, it is a 99. If it is considering as a 25 millivolts, so it becomes a 0.
Sir,
Yeah,
in this question, if the terminals are interchanged, plus
yeah,
comes top and minus comes at the bottom,
yes, yes.
how it will affect the formula?
Yeah, it is a similar to the question number 5th of your graded assignment or question number 4 that we have already
Oh,
discussed.
yeah. Yes. Okay.
Okay. Yes, any other questions?
So in question 5.
Question number 5. This one.
Yes, sir.
Yeah. Consider the current shown in the figure ZL is equal to 100, R1 10, R2 1 and R3 1 kilo ohm. RF is 10 kilo ohm. If the V in V1 is 5 millivolts. Okay, so what is the problem in this? So can you calculate the voltage? Yes, can you calculate the voltage?
Yes, sir.
What is the voltage? If you see that there is a positive feedback as well as negative, both feedback are available. Okay, this is the feedback. If you are using this feedback, this is your negative feedback. Okay, and if you are using the other feedback, it becomes by using the positive feedback also. This one. Okay, so let's take that if V in is applied. Okay, if V in is applied, and what is the output voltage here because of V in? So V out is this one. If I take this in my circuit, negative, positive, Okay, so it is the RS, R1, R2, R3. The value of RF is 10K, 10K, R2 is 10K, and R3 is 1K. Okay, so if it is a 5 volt, okay, I am taking this as a VA. So 5 minus VA upon 10K is equal to VA minus V out upon 10K. So we get the equation of that 2VA is equal to 5 plus V out. Okay. Now this voltage again here VA. So what is the voltage drop at this particular point? This is the VA. So the current going in this direction is VA upon 10K. Okay, the current in this direction is VA upon 10K. Now, if V out, we are getting the current in this direction. So all current will be passing from this. So what is the voltage drop across this point?
Sir,
Yeah,
is VA and VL are equal, right, sir?
which one?
VA and VL.
VA and VL.
Yes, sir.
Where you are getting VL point?
In the given diagram.
VI.
No, sir. In the if you just above the ZL.
Okay, this VL. Yeah, this is the this is the here VL we are taking.
Yes.
Okay. Now what is the value of VL? The drop across this resistance, this ZL. So the value of VL is equal to V out into ZL upon R3 plus ZL. Okay, so VL is equal to V out into ZL is 100 upon 1.1. Sorry, 1100. So VL is equal to V out upon 11. Now this VL and VA are same. So if I put the VL value here, so 2V out upon 11 is equal to 5 plus V out. Hmm. So 5 minus V out. So what is the value of V out? So V out value is 5 into 11 by 9, that is around 6 volt. Okay, with negative sign. with negative sign. But if you see that Vi is negative, so V out is positive. If Vi is negative, V out is positive. So it is around 6 volt. Okay. And if V out is 6 volt, we can easily calculate what is the value of IL. Yes, anyone? How we calculate the value of IL? Yes, anyone? How we calculate the current IL?
Yes, sir.
First we
No,
calculate
and
VL.
If we know that what is the voltage here, okay, so my circuit should be like, I know this voltage 6 volt. Here one resistance is connected and this resistance is connected with two resistance. Simple circuit. Why? Because no current will be going in this direction. It is a virtual ground concept, no current going towards the inside the operation amplifier, so that means the current in this direction is 0. So 6 volt, the value of R3 is 1K, it is 10K, and it is again a 100 ohm. Now the value of R3 is 1K and value of R2 is also 1K. What value we are taking here? Okay, so 6 volt, the current, if I say that the current is I, current is I. So what is the value of current I? I is equal to, these two resistors are in parallel. So what is the value? 1000 multiplied by 100 upon 1100. So 1000 by 11. And this particular two resistance is in series with this one. So plus 1K. 1000 by 11 plus 1000. This is the resistance value. Okay. Current I is V by R. V is 6 volt upon 1000 upon 11 plus 1000. So we can say 6 volt upon, if I take a LCM of 11, so 1000 plus 11,000 is 12,000 by 11. So 6 into 11 by 12,000. This is the value of current. So I becomes 11 by 2000. Okay. So this is the direction. This is the value of I3. Now this I3 will be distributed in I4 and IL. So what is the value of IL? I3 into the resistance of opposite branch,
R2
R2
by
upon
R2
R2 plus
plus
ZL.
ZL.
So I3 is 11 upon 2000 into R2, value of R2 is 1000 upon value of R2 plus ZL is 1100. So cancel out these two, one cancel out with this one, 11 cancel out with 11. So the value of IL is equal to 1 upon 200. That becomes 5 million. Okay?
Sir,
Yeah.
while calculating VL,
While calculating
uh,
VL,
yes, sir, VL, or
VL we are not calculating. We
uh,
are basically check what is the value.
in terms of VO, right, sir? VO by
Yeah,
11.
yeah.
So,
That
sir,
particularly value is only for this point.
yes, sir. So while
Okay.
doing that, shouldn't we consider that ZL also, that 100
ZL
ohm?
ZL for what? For VL.
Yeah, when we say VL is equal to VO by 11.
Yeah. So ZL we consider in this scenario.
Okay.
Actually, there are two loops. If it is only a positive loop, that means if it is a converting connected on a in negative terminal. Okay. So there is no need to calculate the what is the particularly voltage at a negative terminal V1. But
Yes.
there are the loop for both terminal, inverting as well as the non-inverting. So from the inverting, what we are getting the voltage that is the 5 volt.
Yeah. Yes.
How? Directly apply the formula of non-inverting amplifier. V out is equal to minus RF by R1 into VI. RF
Hmm.
and R1 both are same, so V out is equal to minus 5 volt. This is only because of upper loop.
Yes.
Okay, but there is the also the contribution of the lower loop.
Yeah. Correct.
So for this purpose, I have to calculate what is the voltage due to this lower loop. So for this purpose, we have to calculate the V.
Okay. Mm,
Okay,
yeah. Yes, sir.
you there are I not say that this is the only option. You can
Mm.
solve it in another way also.
Yes, sir.
Okay,
Okay.
if you solve this in another way, and if you follow all particularly concept of that one, that is okay. The
Yeah.
answer should be same.
Yes, sir. Okay. Uh, sir, here R2 and ZL are in parallel combination, right?
Yeah, R2 and ZL are parallel when we are talking about the current value.
Yes.
Okay.
Yeah. Yes.
Any other doubts?
Um, um, sir, when we say VL equals VO by 11,
Yeah.
um, aren't we considering only the R3 and R2?
We are considering only the R3 and ZL
Okay.
because the voltage drop across the ZL and voltage drop across the R2 is same
Correct. Yes.
because they are in parallel. So the overall voltage drop across R3 as well as either ZL or R2.
Okay.
That
Yeah.
is up to you. You are choosing the ZL or you are choosing the R2.
Hmm.
Okay.
Yes.
Now any other doubts? Yes. Any other doubts? Satyam, Gaurav.
No, sir.
Thanks for asking, sir, but I'm still stuck in week one assignments, so I'm just listening to what is being discussed for week two.
Okay. Stucking in what particularly? Basically, if we stucking in any concept, I will explain that one, but I can't explain the assignment problems.
Yeah, so maybe in practice assignment itself, like we have question number 2 and 3, or maybe question number 4. I any one of these you can take. I think they
Yes,
illustrate the
exactly.
same
The
concept.
value of VI is not given in that questions.
Yeah,
Okay, I just get this point. VI value is not given.
question number 2, 3, or 2 is means 2. I can still make out it's a negative feedback, but 3 and 4, which are numerical in nature, um,
Hello. Yes.
Yeah.
So this is your Mhm. Yeah.
Yeah. So
So here you are.
question 3 and 4 does not have the value, do not have the value of V in specified, but they
Yeah, V
ask
in value
for,
is not.
yeah,
If you
but
consider the value
in
of Mhm.
in in question number 3 we have to find out VE,
Yeah,
and in question number 2 second part we have to find out the value of V out.
we are
Question
not getting
4
the
is,
V in value is not given here. Okay.
yeah, yeah,
So basically, what we do here for the negative feedback, for the negative feedback, my output should be equal to V out is equal to V in A time 1 plus AF. Okay. The value of A is 500. The value of F is 0.3. Okay. But this
yeah,
formula is applicable only for the negative feedback.
yeah,
If we are
okay,
talking about the positive feedback, the value is V out is equal to V in A time 1 minus AF. Okay. So if V in is given, A and F is given, we can calculate the V out. So first of all, we have to check which type of feedback is this one.
the first one, question number 2, this is a negative feedback.
This is a negative feedback. Okay, so if it is a negative feedback, so V out is equal to V in times A is 500 upon 1 plus A is 500 and F is 0.3. So it is V in multiplied by 500 upon 16.
151.
That is a very dependent on the value of V.
No, the denominator's value will be 151, right?
Okay, sorry, 151. Yeah, 151. Okay.
Okay.
Now if we know the value of V in, we can calculate the V out. In this question,
Yeah.
your V in is 10 volt.
So is
So your
that,
V out
I
is
mean,
V out is 10 multiplied by 500 upon 151. So it is around 33.
is that given like V in
No,
is
not given, not given. Actually, the data is
is missing?
yeah, V in data is
Okay.
missing.
And how about question number 3?
The question number 3 is also same. What is the error value? Okay, so first of all, what
VE
we
is
do?
equal to
First of all, we have calculated the V out. What is the V out value?
V out, V in divided by, this is also negative feedback. So V in by A divided by 1 plus AF.
So
So
V
A
into
is 15 to 20.
15 to 20,000.
Yeah. Divided by A into F, 1 plus 100, 101.
Okay, so V in into 1000 divided by 101. That is V out. Okay, and
Yeah.
VE multiplied by 1000 is V out.
Yeah.
Okay, so what is the value of VE? V is V out
Divided
upon
by
1000.
1000.
Now, if I put the value of VE or V out value here, like if I put the value of V out here, so VE into 1000 is equal to V in into 1000 upon 101. So 1000 cancel out. So VE is nothing but V in upon 101. So if you know the value of V in, you can easily calculate the V in. The data is also missing.
Okay, V in is missing here as well, is it?
V is missing.
What would be its value?
Mm, I think the value is 10. I think value is 10. I think.
Okay, okay, fine. So yes, I think in the graded assignment, uh, this is it for
Sir,
now. Yeah, thank you. Mhm.
Just any other doubts?
sir,
Yeah.
in the same practice assignment, the next question.
Next question.
It's
Yes, sir.
Yeah.
The fourth
How we
one.
solve it?
Yeah.
How we
So,
solve it?
yes, sir. So when k equals 6,
Mhm.
uh, it will be a negative feedback, right, sir?
When k is
mm,
equal to 6. Mhm. Minus, yes. Yeah, it is a negative feedback.
Yes, sir. As
no,
per
sir.
the system and
It should be positive feedback.
Why?
The F value comes out to be negative
Yeah.
with K equal means F comes out to be minus 4 by 11 for me.
Mhm.
And then we are means V out will, if we break the loop, V out will be negative here after F, and then we are subtracting
Wait,
it from V in. So that will make it positive.
wait. Minus 20. Minus 4 by value. If I break the loop and increase the voltage, it will be going downward, upward, downward. Again, it is minus, so it becomes upward. And if you multiply with minus, so it becomes downwards. Yeah, it is a negative.
Well, it's okay. It's minus 20. Okay, but
It is a positive, negative feedback.
yes, sir. So as per the system answer, it is saying it's not.
As per the particularly, okay, in your that part,
Yes, sir.
in your portal.
In our portal, it says when k equals 6, whether it's a negative feedback, and the system answer is no.
Okay. No, it is a basically practice assignment.
Yeah. Yes. So I
Practice.
just wanted to.
Maybe possible that there is some issue.
So when k is 6, it is a negative feedback, right, sir?
Yeah, when k is 6, it is a negative.
Yeah. Yes.
Sir, uh,
Yeah.
in question 6, practice assignment 2,
Question 6, practice assignment.
no, 5, 5.
Yes.
So sir, here voltage across ZL is same as voltage across R2, right?
Yeah, voltage across ZL is same voltage.
So sir, first we calculate voltage across
Let,
R2, then
let,
we can.
wait a minute, wait a minute. Like if I say that these two are short, so that means the
Yes sir.
potential at this point and potential at this point are same.
Yes sir.
Potential at this point and potential at this point is same. Okay, if potential is same, that means the voltage drop at this resistor and voltage drop at this resistor is same.
Yes sir.
Okay, now next,
Now
what is your
sir,
question?
yeah. First we calculate the voltage across R2, then we can directly calculate IL.
Yeah,
Will
you
be
can easily
right?
you can calculate that one also. But for
Yes.
this, you have to calculate the value of VL, na?
Yes sir. So we calculated right 6/11.
6/11. VL we calculate as 6/11. That is the V out by 11. If you get the V
So,
out is 6. If you get the V out is 6, so your
yes sir.
VL is
6
6
by
by
11.
11 multiply by. So okay, this is the VL. Now what is the value of current? I is nothing but VL by R. Okay.
Yes sir.
Sir,
Yeah.
here for calculating VL equals V out by 11,
Hmm.
it's the we are using the formula that R2 by R3 plus R2 of V out, right?
Yeah. That is
Uh,
the formula. I am not going in the formula part.
yes. So
Okay.
sir,
We are solving with the circuit. We are not going
hmm,
with the formula part. That's why I am taking this one. Otherwise, there is a formula for this one also.
yeah, yes sir. So sir, but before that we also make the parallel equivalent of R2 and ZL, right?
Yeah. Parallel R2 and ZL.
Um, uh, did we do this in this calculation?
Mm, this is only if you are we are using for the calculation of the current only.
Um, um,
Which calculation you are asking that?
Here, when we say VL equals V out by
By
11.
11. Yeah.
Yeah. So it's purely by considering R3 and R2, right? R2 by R3 plus R2 of V out.
R2 by, yeah, R2 by R3 plus.
Yes, sir. So it can be that only when ZL is absent.
We are taking this basically what I do here is that I am just considering my current will be going in this way. Okay, the current will be going in this way.
Yes, sir. But I3 also has IL also, right? It is
Yeah,
dividing.
I3 and IL both are different. Na? So we have to calculate the I3. I have to calculate the IL for that. So that's why I calculate the value of I4.
Yeah, yes, sir. So,
Okay.
so
So my consideration is that I have to calculate first I3, then calculate IL, then calculate the I4. After that, I
mm,
exactly calculate the value of VL.
yeah, sir. So yeah, for because of this ZL presence,
Mhm.
we first need to calculate the parallel equivalence of this ZL and R2, right? For calculating VL.
No, there is no need of that one na, because it is a parallel, and if we are talking about the voltage, so in the parallel the voltage is same. Na.
Mm. So then if even if we consider only R3 and ZL, then we should also get the same answer, right?
Yeah,
Um,
R3 and ZL. Yeah.
but are we getting the same answer, sir?
the value of V out is changes in that scenario.
Okay.
But particularly the consideration is that my loop is not completed.
Okay.
Okay, my loop is not considered. Basically, wait a minute. We have to calculate this V1 voltage. Okay.
Correct.
And
Yeah.
V1 is equal to the V2.
Correct.
Why? What is the value of V2 at this point voltage?
Yes, VL.
Okay.
Yes.
And what is the voltage at this point?
VL.
Either I am considering this voltage, this current multiplied by the resistance. This is
correct.
this voltage, or either I calculate this current multiplied by the ZL. The voltage is same.
Yeah, correct.
Okay. So there is no issue for that.
Okay.
But one unknown parameter of the current is also added here.
Okay. Yes. Yes.
Okay.
Yes, sir.
Any other doubts?
Sir. Regarding the labs, what stage it is in?
I think the lab will be started. Okay, let's. If your doubt is completed, I just stop the streaming.
चेंज कर लो
चेंज करें उसके बाद